Welcome to Notebook 43, Document Tagging. In this notebook, you're going to extend your skill set of generating structured data by learning how to extract data and tag it as you specify out of long-form text. By the time you complete this notebook, you'll be able to construct Pydantic classes that represent collections of other Pydantic classes, and you'll be able to perform extraction and tagging against long-form text. We'll begin with importing what's necessary for this particular notebook. There's nothing new here from the previous notebook. And as usual, instantiate our LLM instance. So let's talk about document tagging. Knowing what you already do from the previous notebook about creating Pydantic specifications for structured data generation, you're going to have a really easy time extending this skill to being able to extract and tag data out of long-form text. To learn the technique, let's assume that we want to extract the name of any piece of fruit mentioned in a piece of text. Right? We'll begin, as we have been, by defining a schema for our data, instantiating a parser that, in conjunction with a prompt, using the parser's prompt instructions, we'll be able to parse structured data out of our prompt and what the LLM can ascertain about it. Okay, so it's going to be a really simple class definition. Again, we're going to inherit from base model, take care to imply or to supply a helpful doc string. We have a single field, which is a string, which we will call name, which we will specify as being the name of the piece of fruit. Kind of following this cookie cutter approach from the previous notebook, we will instantiate a JSON output parser using the Pydantic object that we just defined. We will get the format instructions from the parser using the get format instructions method. We will reuse the prompt template that we used in the previous notebook since it seemed to work well for us. It includes the system message, a parameter for future input, as well as a position for the format instructions, which we are mentioning should be utilized in our prompt. For the sake of convenience, we will partially apply the format instructions into our prompt template, and we will then create a chain using our partially applied prompt template, our LLM instance, and our JSON output parser. So now, okay, it's still very simple, but we're going to do something slightly different than what we did in the previous notebook. Instead of providing a single entity, which is meant to be transformed into a structured data entity, for example, we provided a book and got book details. We provided a city and got city details, right? Instead, we are going to provide free-form text. And in this case, the free-form text is an apple fell from the tree. Now, given the simplicity of the following statement, it probably won't come as too big of a surprise that our chain is well capable to identify and capture the single piece of fruit mentioned. All right, so here we've done kind of our first instance of document tagging. Again, we're not providing an entity that's meant to be converted into a piece of structured data. I mean, we kind of are, but rather we're providing free-form text, and we're asking the large language model to extract data that we have defined as relevant, in this case, a piece of fruit, and then structure that piece of information along with anything else that we want to specify, which we didn't do in this instance, into structured data, right? So from this free-form piece of text, we've gotten structured data, all right? So when it comes to extracting and tagging multiple data entities out of free-form text, there's one ingredient that we're missing, and that's the ability to specify that rather than capture a single data entity from a given piece of text, we wish to extract a list of some defined entity, and that list might be of arbitrary length, right? We've got free-form text. We don't know how many of that particular kind of entity is in the text. But rather than capture one of these things, we would like to capture a list of these things. So using Pydantic, this is really straightforward. We're also going to use the Python's built-in list from typing.list. All we have to do is create a new Pydantic class. So here we are. We're going to define fruits. It will inherit from base model. We'll give it a helpful doc string. This time it's the names of fruits, and it'll have a single property, which is fruits. But here we're going to specify, instead of using our field with a description, we're going to specify that it should be a list. And where did we get list from? Well, we got this from Python's built-in typing. And it should be a list of type fruit, which we have defined above. Okay, so basically a lot of the important information is actually captured in the class definition for fruit above. But here we've taken it one step further and defined a new class, which is a list of another class that we created. Okay, so with the list bearing fruits class now at our disposal, we can construct a parser and a chain as usual, but this time we'll use fruits instead of using fruit. So again, we get an instance, we get an instance of our parser, but this time the Pydantic object is fruits. We'll get our format instructions off of it, apply it to our template, create the chain, and now we will invoke our chain with a longer sentence. That sentence being, an apple fell from the tree, it hit the ground right next to a banana peel. Okay, so you and I can look at this. If we're actually interested in getting the names of all the fruits in this particular piece of text, we know that it's apple and we know that it's banana. But let's see now that this chain is using the output parser that expects a list of type fruits. Let's see how it does, and it looks like we got back a nice Python object. It has a fruits key as we defined here, and sure enough, the fruits key is a list, and each item in the list is its own JSON object that has a name property followed by the piece of fruit that was mentioned inside of the long form text. As a further exercise, if we wanted, you can see we have uppercase apple, uppercase banana, which is not how they showed up in the freeform text itself. Maybe we want to do something about that, maybe we don't. The point being that we've just learned how to create classes that are created as a collection of other classes, right? Including the ability to form properties on the class that are a list of other class types. Okay. So with that in mind, that ability to create that next level class is really all you need to know how to do document tagging. So we're going to go straight into an exercise for y'all. This one's a little bit longer. You might even consider it one of our mini projects, but here's how it's going to work. Below, which you can read here if you want, in this long string called Apollo Story, is an account of the Apollo 11 landing. You can read it if you like. Your goal for this exercise is to extract and tag several entities from within the account. Specifically, you should extract and tag the following. You're going to want details about the entire landing. Okay? And the details about the entire landing should include, first, a list of any crew members mentioned in the account. And for each crew member, you should capture their name and their role during the mission. You need a list of parts and modules belonging to any spacecraft that was mentioned in the account. And for each part of a spacecraft extracted, you should capture its name and the specific part or module of the spacecraft that it is. You should also capture a list of any significant quotes made during the account. And for each of these significant quotes, you should extract and tag the quote itself and also the name of whoever the speaker was of the quote. Okay, so there's several steps you're going to need to take to accomplish this. We're asking you to tag several bits of information out of this longer form account. So if you want and you feel up for it, jump right in. This is definitely one of those situations where you're going to need more than one cell to work in. So don't forget, you can always create new Python cells using this plus button, or as my tooltip says, you can use the keyboard shortcut B. If you're interested in a little bit of guidance, you can click here to expand this walkthrough. The walkthrough is going to set out each subtask, as we approached it at least for this project. A chance to accomplish that subtask on your own, and then also a solution for that subtask. And after going through several subtasks, you'll kind of arrive at the final end intended goal of this mini project. So whichever way you choose to tackle this, go ahead and set to work and pause the video. And whenever you're ready, we'll expand the walkthrough and go through it, including each of the solutions for the sections in the walkthrough. Okay, good luck. Okay, I hope you were successful at this document extraction exercise, and especially after completing it, I hope you're really starting to get a sense for how powerful this technique is, right? We're working with a relatively small document actually at this point in time, and we're kind of pulling out trivial things, but it's easy to imagine in your work, in your organization, any number of pieces of text that are laying around for whatever reason that you would wish to perform analysis on, or I mean, you name it, right? Like there's so many applications to this technique. Okay, so let's expand the walkthrough. To begin with, and excuse me, I think I need to define the Apollo story. To begin with, let's define the crew member details. So following the guidelines above, create a class that represents the details of a given crew member. If we look at that here, we used a Pydantic class to identify the details of a crew member, including a string each for their name and their role, which is the role of the crew member in the mission. Okay. We need to do something similar for the spacecraft details. There's really not much new here. We're just creating another class to contain the spacecraft details. Similarly for significant quotes, nothing really new here, but we're defining yet another class for significant quote that has the quote as well as the name of the person who said the quote. And now maybe a little bit trickier. Definitely this is in line with the new technique we introduced in this notebook. We need to define a combined details about the entire landing. So here we create a class called Apollo 11 details. You probably named it something different. Again, it inherits from base model. These are the combined details of the Apollo 11 mission. And you see as its entities, we have crew members, which is a list of type crew member defined above. We have spacecraft details, which is a list of spacecraft details defined above. And finally, we have significant quotes, which is a list of type significant quote defined above. Okay. Next, we need to create the extraction chain. Nothing new here. We're doing exactly what we've done each time we've used this specific structured output approach. We end up with a chain that is ready to take long form text and extract based on the Apollo 11 details object that we've created. And now if we invoke the chain, you can see we will store it in Apollo 11 details. We're expecting back a JSON object, so we're using the pprint here to get a nicer printout. And you can see we got a really nice result here. We have all the crew members mentioned in the document, namely Neil Armstrong, Buzz Aldrin, and Michael Collins. We have their roles in the mission. We have extracted two significant quotes, one by this Neil Armstrong and one by the narrator of the story itself. And we can see that we got informations as well about the Columbia Command Module and the Eagle Lunar Module. Okay, so this is really fantastic, right? Like the ability for the large language model to take this freeform text, structure this output for us just as we specified. It's really powerful stuff. So in summary, this notebook concludes the section on structured data generation, which we hope you'll agree is a really powerful tool. And the sky's the limit thinking about the number of applications that you could apply this to in your own work. So, related to their ability to generate structured data, LLMs can generate structured data intended to indicate when and how an application ought to invoke potentially non-LLM related functionality. Okay, we're going to cover this in much more detail, but we've looked at structured data as being something to represent data in our inputs, right? But you can also imagine a data structure that indicated a function that ought to be called, right? And specified the arguments that we ought to pass into that function, okay? So this use of functionality in our application that is not actually the large language model itself, but is the large language model indicating that a certain bit of functionality ought to be called, and how we call this tool use. And in the next section, we're going to look at how we can create tools and use tools, and we'll also give a small introduction to something called agents, which are a way of thinking about and programming LLMs to use multiple tools in an elegant and powerful way. Okay, so without further ado, we will see you over in section 5. Just as a reminder, you can get there by clicking up one level on the file viewer here, going into 5 tools, and then you can open up the section introduction for section 5. All right, see you there.